Gentlemen, I'm Bryan Zimmer from Netflix. I'm a senior security engineer there. I'll be talking to you about our location-independent security approach, or LISA, today. So what is LISA? As the name implies, it's a security approach, security architecture, where we're no longer trusting our network location to provide access. So in other words, just because you're in our office doesn't necessarily mean you get any access to our corporate services. Instead, we're trusting authenticated users and devices. It shares a lot of the principles with Google's BeyondCorp, if you've heard about that in the last few years. Basically deprovisioning the corporate network, treating your office network as a Starbucks network, essentially. We took a slightly different approach to it, as you'll see. So why? As any pen tester will tell you, probably the easiest way into a corporate network is to just tailgate into the building and plug into the network. So we want to shut down that pretty easy avenue into corporate services. At Netflix, we want to maintain a fairly open campus, so easy freedom of movement throughout our campus. We don't want big fences, we don't want man traps, spikes coming out of the floor, that sort of thing. So moving from physical security, focusing more on electronic security, logical security instead. Also, we want our employees to be able to work from anywhere without geographic restrictions so that you have the same experience both in the office, out of the office, at home, at Starbucks, at wherever. You get the same access, same experience. And help accelerate the death of the perimeter. All the cool kids have been saying for a while now that the perimeter's dead or dying, so we figured why not take it to the next step and just say, well, forget the corporate office, that's no longer trusted as well. Just cut that out of the perimeter. So some of the benefits. Reduced attack surface, so shutting down that easy avenue into corporate services where people can just tailgate into the building. Because you could be spending millions of dollars on your electronic security, but if someone just walks into the building, it's pretty much thrown out the door. Someone recently asked me, well, how do you guys stop man-in-the-middle attacks, on your network or even on other networks? And I said, okay, well, we've got the typical stuff, your DHCP inspection, your ARP snooping, or ARP inspection, DHCP snooping, all that sort of stuff, yada, yada, yada. But now that we have LISA, we don't really have to worry about people man-in-the-middling us anymore. It's basically a VPN protecting your connection. So someone can man in the middle of you all day. They're not going to get access to the communications. The worst they're going to do is DOS your ability to connect to the VPN. And since everyone's coming into one central point, no longer accessing from trusted locations all over the place, you've got one central place where you can do authentication, two-factor authentication, doling out access, controlling access, and doing inspection of all that traffic with your fancy network security tools. And then also at that same point, you can do endpoint checks, doing your typical, is the device healthy, is it patched, is the firewall on, is the disk encrypted, all that sort of stuff. So another benefit, simplified network architecture. So not only treating your network, the trust level of your network as like a Starbucks network, but also simplifying the infrastructure as well. Because maybe you don't have that expensive $1 million security stack out in your office in Mongolia because you couldn't justify it or you couldn't afford it or whatever. So, well, why not just scrap the one in the big office as well? Maybe you don't want to, but in theory you could. You don't need 802.1x to protect your ports. You don't need all those, the ARP inspection, all that sort of stuff, and fancy network security stack, because all that inspection and all that control is done at your VPN endpoint, be it in the cloud or in your data center, if you have one. And then you get the same solution inside and outside the office. Because your expensive network security stack can't protect your users when they're at Starbucks or one of the Regis offices or whatever office you're renting. So this provides the same solution both here and there, and it protects you equally in both locations. Little or no custom development. So most IT shops don't have a bunch of developers on hand, like some certain other large corporations, to just throw at this and write a custom solution. So we went with commercial off-the-shelf software like most people would do and just bolted it together. It's nothing, there's no magic to see here, it's just stuff everybody can do. And because you're not doing any custom development, you're not tied to a specific specific set of supported vendors. So if you swap out VPN vendors or you swap out 2FA vendors or what have you, you don't have to rewrite a bunch of integrations and custom development, all that sort of stuff. Endpoint checks. So at Netflix, we're big on MYOD. I thought I coined this term like half an hour ago. Apparently not. I did some Google searching. Somebody else came up with it a couple years ago, but oh well. So manage your own device. So people are free to go out to the Apple Store, grab their own device, and then start using it for accessing Netflix services. But we encourage, instead of us tightly controlling and centrally managing their systems, it's more about giving them the freedom to do what they need to, use whatever device they want to, but making them responsible for managing their own device, making sure it's patched, making sure it's, it meets our standards. And so the data we're gathering from the endpoint checks and from VPN logins and internal application logins, that all feeds into what we call user-focused security, our big user-focused security project. Stethoscope and Train Man are the two big parts of that. If you were at ShmooCon last week or the week before, Jesse, Chris, and Andrew White presented on the stethoscope portion. So that's basically enabling the users to do this managing your own device thing. So, hey user, you're trying to log in to service X or the VPN or whatever. Here's a page, a web page of like, here's the five devices we've seen you accessing services from, like your phone, a couple laptops, what have you. These ones are green, they're all good, but this one's red. So here, click here, and here's a couple steps you need to do to turn that green so you can now access corporate services again from that. And that helps educate the users and empowers them to kind of do it themselves. And then also Train Man takes all that data in and does machine learning and anomaly detection and all the greatest buzzwords to detect unusual access of applications or data or the VPN. And those will be open sourced soon, from what I hear. And our 2FA provider and Google Auth also have some basic health checks. So that helps cover SaaS users that don't need VPN to access our corporate services, like people who are just using Google Apps or Slack or what have you. Methodology. So when you plug into our corporate network, all you get is internet access and VPN access. You don't get anything else. One of the big ones that shocks people is you can't even talk to devices next to you, say your neighbor or your NAS or whatever you had in the office. And you also can't talk to other subnets in the building. So luckily, with most of our users, this wasn't an issue because they've already been pushed to move everything they can up into Amazon. But for some other companies, this may be a bigger issue. And then if you want to access private resources in AWS or your data center, you have to then connect to the VPN. So one big thing is remembering to remove building whitelists from AWS and your data center, your applications, everywhere you possibly can, because if you're going to no longer trust the corporate network, you want to make sure that you're not trusting it in every possible spot you can, because maybe you blocked it in your firewall going over to your data center, but you forgot that there's, when traffic goes out the internet and comes out as your public IP going to your public-facing stuff, well, the building gets some special extended access to either test and dev resources, or it bypasses some auth checks or something like that. So you want to get that out of there as well. And don't forget redundancy and circular dependencies. So when you're funneling everyone to one point into your corporate environment, you kind of want to have some redundancy. So of course have your redundant VPN stack, but then also have it in multiple locations. And don't forget circular dependencies where, say your VPN goes down or your auth provider goes down, and then you can't auth into the VPN, so everyone's screwed. You may want to have a secure location on site behind a locked door, all that sort of stuff, to bypass some of these rules so you can get in and fix things in case of an emergency. Collecting use cases, how do you find all them? So as scary as it was for me, I had to get out from behind my monitor. I had to go talk to people in real life. So it helps to go find those employees that have been at an organization for a long time. They've got all sorts of tribal knowledge. It's really helpful. Look for interesting branches in the org chart. You know, okay, well, these guys all do pretty much normal stuff, but this one looks like a little odd corner case, or these people look like snowflakes. Let's go talk to them. Talking to directors and saying, hey, we've got these use cases we found. Do they match your use cases? Is there anything that's not going to be covered for you by these? Do you know of anyone else that might not meet these use cases? You know, getting out there, making friends, finding that guy in the basement with the suspenders and the beard, talking to him. He's always a nice guy. Luckily for us, most people at Netflix only need internet and VPN access, so that kept things fairly simple for us. But consumer electronic devices. So I don't know if you guys have heard, but Netflix has this cool app that runs on TVs, lets you stream movies and stuff from the internet. Check it out. The problem with that is that, so say TV vendor X goes and develops their Netflix app, and they throw it on the TV, they ship us the TV, and they say, hey, can you guys bless this, do your magic checks and whatever, and make sure it's good to go. And so we bring it on site, and we run a bunch of tests and say, yeah, it's good, okay, go for it. Now, with Lisa, with everything needing VPN to get access to corporate services, last time I checked, no TV support VPN, so damn it, there's a problem. And then also during these tests, you know, sometimes the TV needs to talk to, say, some other device, like the engineer's laptop that's running some code, or their phone needs to screencast to the TV, something like that. So that's also blocked because of the device-to-device local subnet communications are blocked. So creating exceptions, taking care of the snowflakes. So we've got two exception networks. We've got one which is limited Amazon access for testing these consumer electronic devices, just accessing dev and test resources. So the TV can talk to a test harness, or it can talk to the server where it's got some code running on it. The second one is for full Amazon access. This one is our scary network that we like to control very tightly because it's basically bypassing all these protections we set in place. So it's people on there are usually on there because of VPN client limitations, because say for some reason your vendor doesn't have feature parity between Windows and Linux. That would never happen. Or high throughput stuff. So say some of our video encoding guys need to download terabytes of video from Amazon and play with it on their laptops. When they're used to a 10 gig connection to download that stuff, or then suddenly you stuff them over VPN, it's maybe not so much 10 gigs, they get upset. So with these networks, you want to review access and track it and automatically deprovision it. So we've got a sign up form where people can sign up and request access, and we kind of do a sanity check and then say, okay, yeah, go for it. And then we've got, and we track all those and then automatically deprovision their access if they haven't used it for a while. We'll ping them and say, hey, do you still need this, that kind of thing. And then in the long term, these networks will go away, and we're working on some small custom Linux boxes so that you can plug the box in, say, on the Lisa network or at home or wherever, and then you off to that box so you can plug in, and then that'll get you over VPN the corporate services. So that'll take care of these TVs and all that sort of stuff. So I'm a visual guy. I like diagrams. Sorry, the word's a little small. But it's just kind of it's an overview here. So here's the corporate network with your workstation. Services are allowed to access the internet and VPN, and that's the VPN is how you get access to private Amazon resources. And then once you're on VPN, you can then come down into the corporate network to access other devices on the office network. And then here on the exception network, you can talk device to device, and then you can talk to only test and development resources there. And then this is the example of what's not allowed. So device-to-device communication, talking to corporate resources, private AWS resources when you're not on VPN, and then these two subnets can't talk to each other. So pilot networks. There's nothing more fun than flipping the switch on go live day and having people just standing outside of your cube with a bunch of pitchforks and torches. So set up some pilot networks ahead of time so people can test out their use cases, make sure everything is hunky-dory with them, working out minor issues. Hey, the VPN client doesn't do this, or hey, I don't have access to this. Make sure those get fitted into the use cases. tuning workflows, because people are going to have to add a couple steps to their day, or they've got to off in the beginning of the morning, what have you. Just getting them used to the new way of doing things. And then tuning documentation, because if you're going to be communicating out to everybody, hey, here's the 3 steps you need to take to get ready for this, and you forgot part of step 2, or they crash and burn on step 3 because they didn't understand it, this is a good time to work all that sort of stuff out. Finding hidden use cases. No matter how good you are, there will always be that one use case that somebody, either you didn't think of or everybody else didn't think of. So getting as much of those out of the woodwork during the pilot network phase is the best way to go. And then, of course, there's always going to be that one that you didn't think of on go live day. So being prepared to take care of that quickly is pretty much the best for us. Let's see. So for automated deprovisioning, we pull the switches and ask them, hey, what are all the interfaces on this exception VLAN? And then the interface description has the jack number, the wall jack number on it. So then from there we can tie over to the cube number. And then the cube number we can match to a user in our HR database. And then from there we can email the user and say, hey, do you still need this jack, say every 6 months or whatever, or automatically deprovision it if they don't respond, or if the jack goes dead for a while. Communication. So this is always a fun part. So at Netflix, to get a big project started, leadership writes a memo about, hey, here's the project, here's the idea, here's what we're going to do. And then they get all the engineering leadership together in what's called tech strat, or technology strategy sort of meeting. And so they sit around and first they read the memo and they debate everything and come up with a final solution, tweak the memo, tweak the plan. And then there's the kickoff. And so then you have to make sure you pull in the right teams, get the right resources involved. So for us, security was leading this. So of course, getting in the right people from security, then getting the network team, because they're of course going to be implementing all this. Getting the help desk involved, because they're going to be dealing with all the users who say, hey, the VPN's screwing up today, or I can't access this or whatever. And then of course the people who are going to be on the exception networks, because they're probably your biggest customers. Everyone else will typically just not even have issues, but then it's always those corner cases that you'll be wanting to communicate the most with. Targeted emails. So at Netflix, we don't really like doing blast emails to the entire company, because people tend to get alert fatigue or maybe just ignore them. So we went with focused emails of, hey, user X, we saw you use this service in the last 30 days. You're going to be affected in this way, so please do these 4 steps to prepare. And that helped people realize, oh, okay, this applies specifically to me. I should do these things. This is coming, that sort of thing. Flyers and strategic locations. So what is the one strategic location that everyone uses, unless you're some sort of freakish camel? The bathroom, yes. So we put flyers up on the bathroom doors pointing to a bunch of project resources, such as our Google group where people can ask questions, our Slack channel where people can ask questions, our Q&A document with questions, naturally, a website with various steps and information. Hell, we'd even take postcards if people wanted to contact us that way. And then, so we also had some in-person options where we had town halls. So people, this is where a couple times where I'd come in and present and say, hey, here's an overview of Lisa. Here's how it's going to affect these different groups. Do you have any questions? That was fairly successful. Office hours, where kind of like in college or university, the professor sits down for an hour every week, and you can come in and ask questions. So I did that, and then also a war room the day of. Originally, we were going to do our war room kind of next to our little area, but we decided, oh, well, actually, let's move it down to where the help desk is, so we're kind of in the trenches with everybody, seeing all the issues coming in, kind of keeping our finger on the pulse, and that worked out really well. And then, did you get everyone? Because you're not blasting the email out to the entire company, can you be sure you got everyone? Well, I mean, based on these options, it's pretty thorough, but there's always going to be somebody or some group that will make you cry, like the day I almost cried because somebody passed me in the hall and said, hey, Bryan, what's this Lisa thing about? Like, didn't read the flyers? He's like, no, I saw the flyers, but I didn't actually read what it said. Anyway. So in our office hours, I had a stack of beer and I had this sign out to attract some attention. That's one way to draw people in. Free beer is always good. I must look really intimidating because nobody took that beer except for a couple coworkers. Maybe they're just trying to humor me, but anyway.
Bad beer.
It wasn't that bad, Bob. You don't even like beer. Branding. So any cool project at Netflix has to have a logo. And so I had one of our internal UI guys do up a logo here. And so we had, as you can see on my laptop, Lisa stickers. We had Lisa shirts. We had Lisa pens. We had Lisa flamethrowers. Spaceballs reference for you. It helps with the messaging, the branding, tying everything together, tying in the different, the flyers and the website and the email and everything. If you want stickers, I have some left. Let me know. So quick little comparison to Beyond Corp. So Google, as I mentioned, has a lot of developers and a lot of resources to deal with these kind of problems. So they wrote their own custom, really thorough, really awesome solution. But it's a lot more work. It's a lot more custom. It's a lot more involved. Requires a lot more resources. They also have really strong endpoint controls. They use a lot of PKI. They also have stronger centralized management of their endpoints. They expose a lot of their apps to the internet and putting proxies in front of them rather than using VPN. So Lisa has some of the same basic principles, but we went about a different route of achieving this. So you get the same basic features, but a smaller feature set, and it's a lot more achievable for most companies, especially small companies. And if you still want to go to Beyond Corp down the road, this could be a nice stepping stone to it. That's it. Any questions?